What's up, folks? Hobbs here. We are going to talk about our first lactate myth. One of my first ones that I kind of talk about the students with way before we even get to it. I always ask them, like, hey, how many of you have been sore? You know, we kind of talk about within the first couple of days of class. Usually one of the things I talk about, because I want them to start thinking about, like, hey, are all these things you believe about exercise and nutrition and things, are all of them true? So one of the first ones I bring up is that, and I'm like, see, so it opens them up to maybe, I don't have all this figured out, this class is going to teach me things that are valuable to me. So anyway, lactic acid or lactate is the cause of DOMS, right? Or delayed onset muscle soreness. So is that true, right? Like, so most of us believe that, most of them don't. I'm going to say that. Many people believe that, because that's something we've heard probably for a long time. It's something I believed until I went to college. So anyway, now here's what we're just going to think about this for a second. Now, usually, like, DOMS or delayed onset muscle soreness usually peaks at 48 to 72 hours after the exercise, right? After that bout of exercise. It can peak at 24, right? We're just talking about general ranges, right? But any of us that have been sore or like really sore and done something, we usually know, like, 48, 72 hours, right? It kind of, like, that's when it's the worst. So, all right. So whatever's probably causing that has to be there in relative abundance at the moment that the DOMS is peaking, right? That the pain is peaking, right? So let's think about this for a second. So we're going to talk about something called half-life, right? And what I mean by half-life is we're going to look at a substance and see how quickly does the body get rid of, break down, etc., that substance, right? And so what the half-life is the amount of time it takes for the body to get rid of half that amount, right? So just making up a number, keeping it very simple. If at the moment we measured it, there was 100 of something, right? And its half-life was 30 minutes, right? What that would mean is when we measured it in 30 minutes, there would be 50 of something, right? So whatever it is. So let's take that example and apply it to lactate, right? Super simple way to think about this so it doesn't get over sciencey. The half-life of lactate, in general, most people, right, is 10 to 20 minutes on average. That's not a contentious statement. That's not something that's really debated. You can readily look up that information available on your phone, the internet. It's readily available. It's not. And if we think about it, that means when our bout of exercise finishes, that means in about 10 or 20 minutes, half that lactate that is above our resting level, right? Because there's always going to be some level of lactate. Half that level of lactate, right, is gone in 10 or 20 minutes. And in another 10 or 20 minutes, another half of that half, right? And then another, and then another, and then another, and then another, et cetera, right? So if we think about this and do a thought experiment in our head, and we take this out, like at 48 or 72 hours after that bout of exercise, there's none really of that lactate left. There's no significant amount of that lactate left. And something we don't even go into, there's even less of it in the muscle, right? We'll look at later, like, how quickly the body moves it in normal populations, moves it from the skeletal muscle into the blood, right? It is incredibly fast, right? It's incredibly fast. So you excel at that. You really do. As a human, right? It moves out really quick, right? So even if we were going to say it's still there in the body, what's left in the skeletal muscle is almost nothing, right? It's going to have baseline levels. It's never going to be zero. There's never going to be zero lactate in your body. Never, right? Relatively speaking. Anyway, if we do that, we can see that it is not what causes DOMS. Excellent question. That's something I'm definitely going to talk about. I'll have probably a whole lesson kind of like this about, look, it's not, we don't know for certain We know some things that it's probably not anymore that we used to think, like maybe it's this, right? Maybe it's edema, maybe it's the nociceptors or these nociceptors that are like your pain receptors, like maybe they've been denatured, right, because of the acidic environment. Maybe it's micro tears. And anyway, we don't really necessarily think it's maybe any of those, but well, there's some thought it has something to do with the muscle spindle. I don't want to get too much into it, but I will talk about it later at some point. But it's a whole lesson into itself. But what it's not, right? With the best evidence we have today, the vast amount of evidence we have today, right, it says it's not lactic acid or lactate, which is really what we find about. Anyway, that's it. And I will flip the board and we'll go to our second myth. I'm going to flip the board.